Hi, I'm Liz Needham. Let's have a look at what mutually exclusive is. So mutually exclusive events are things that cannot happen at the same time. So for example, you can only go in one direction at a time. You can only have something being hot or cold. You can't be both at the same time. So let's have a look at what this looks like both in Venn diagrams and tables. So for a Venn diagram, when we talk about mutually exclusive, what we've got is we've got circles that do not overlap. A is separate from B. They are different things. There's nothing in common. So that means when I talk about the union, and you'll notice how I've got the two circles shaded in red there, when that union is equal to the probability of A plus the probability of B, then if that statement is true, then we have mutually exclusive events. If I have events that are not mutually exclusive, then what that looks like in my Venn diagrams is that I have circles that overlap. So the union of A and B is not equal to the probability of A plus the probability of B. So let's have a look at an example there. If we want to know whether getting a black card and a heart is mutually exclusive from a pack of cards, we need to think, well, right, in a pack of cards, we know we've got hearts as one of the four suits. So the probability of a heart is 1 out of 4. The probability of getting a black card, well, it could be either spades or clubs, so that's a half. Then I want to know what's the union of hearts and black cards. And in this case, that union is 3/4. So according to my rule, I need to now work out whether these probabilities are the same. So the question is, does a quarter plus a half equal 3/4? If it does, then we have mutually exclusive events. If it doesn't, we don't. And in this case, they are equal. A half plus a quarter does equal 3/4, therefore they are mutually exclusive events. What about this example? So is getting a 6 and a heart mutually exclusive? So to get a heart, probability of that is a quarter. To get a 6, the probability of that is 1 out of 13. So remember, there are 4 suits, and in each suit you'll have a card that is a 6. So that's why it's 1 out of 13 for each one. Now, one of those 6s will be a heart. That's why I've drawn my circles as overlapping. So the probability that the union of a heart and a 6, that probability, when I've worked it out, is 4 out of 13. So according to the rule, we ask ourselves, does a quarter plus a 13th equal 4/13? And in this case, the answer is no, it does not. Therefore, this is how I show that a 6 and a heart are not mutually exclusive. What about if I have it as two-way tables? What does it look like there? So here's our table. We've got two events A and B, and notice I'm interested in the intersection. If that intersection, so if I've got two separate events, they don't connect together at all. If that intersection is 0, then the events are mutually exclusive. If the probability of that intersection is not 0, then that means that I have events that are not mutually exclusive. So let's have a look at this example. Is the probability of getting a black card and a heart mutually exclusive? So when we look at our table, you notice I've shaded in red the probability of a heart and a black. That probability is 0. So because the intersection between hearts and black is 0, that means these are mutually exclusive events. If I make a table here looking at the probability of a 6 and getting a heart, you'll notice there the intersection between a heart and a 6, that probability is 0.0192, which does not equal 0. Therefore, getting a 6 and a heart are not mutually exclusive. Thanks for watching.